Hey guys, welcome back to the old mill shed. Today we're going to try to figure out why my old metal chop saw isn't working as it should. So a little background on this. This was originally my dad's. I think he bought it somewhere in the early 90s. There's not a lot of parts made for this anymore, and this can actually be replaced. Same brand, same basic style for about $120. So we're not going to put a lot of money into this to get this going. However, I did have a set of brushes that would go in it, and when I would pull the trigger, this thing would immediately trip the breaker. So I just threw a set of brushes in it. The last 3 or 4 times we've had that happen over the years, that fixed it. So I did it again this time and it didn't work. So we're going to tear this apart. I'm going to show you how to test the armature. We're going to test the switch itself, which I believe to be okay, as well as the power cord, which I believe to be okay, and then the field windings, the coil stack. We're going to check that as well. If we don't see anything wrong, we're just going to give it a good cleaning, and if that doesn't fix it, it's probably going to be the end of the road for this particular tool. Like I said, the only thing you can still get for it are the brushes, and a few screws and things of that nature, but they're obviously not the problem. So I'm going to get this tore down and I'll be back. Okay, so the first test that we're going to do is we're going to hook the probes here into each leg of the cord. And it doesn't really matter which probe you put on which blade at this point. We're going to hit the switch and see if we make continuity on our meter. Okay, so here we are down at the switch. Now I do get power to the motor when I squeeze it, because it wants to short out once I pull the switch. What I'm really looking for here is I have my neutral side and I have my hot side. So what I want to do is make sure that we're not getting a short across the switch. So I'm going to put my meter on continuity, test it. Let's see, as back is out a little bit. There we go. Alright, that side's good. What if I could get it to go down in there? Alright, so it looks like this switch is working properly. So you can see it's coming in from the power cord. We have our neutral and our power, and then coming out we have neutral and power, which is blue, going down to the field windings. So let me finish getting this off and I'll rejoin you when I'm down inside of the motor. Okay guys, so I tried to pull this out and I think it's epoxied in there. It wouldn't budge. I didn't want to break anything. And I'm sorry for the shakiness. I'm having to hold the camera by hand because the camera tripod is currently holding a light so you can see up in here. So I'm going to try to explain how this works the way it was explained to me. So you have your common wire and your hot wire coming from your switch, and each one of these wires corresponds with a winding inside of this motor. And if I'm not mistaken, I think this one's blue, this one's the white one, or maybe this one's the blue. It doesn't matter. And it goes through here and it has these windings, and they are insulated from each other. And then one wire, after it goes through these windings, connects to a brush back here in the back. One for blue, one for white. And the brushes go onto the commutator here, and the electrical field feeds back through the armature, and the magnetic field created there and in here attract and oppose each other, causing this to spin. If some of you electricians out there have a better explanation, feel free to drop it in the comments. I'm a machinist, not an electrician, but this is my basic understanding of it. So what we want to do is check this wire and see if it has continuity to one brush holder and not the other. And then we want to check the white wire and see that it has continuity to the opposite brush holder and not the other. So let's just say this one, and I haven't checked them yet, let's just say this one has continuity to this brush. We want to make sure it does not have continuity to that brush. And then this one, we want to make sure it has continuity to that brush, but not this brush. And if all of that checks out, then we want to move back and do our adjacent continuity or opposite continuity, and we want to check the ohms on all of them, make sure all the ohms are close together. And then we want to make sure that none of the commutator bars have continuity to the shaft, which is connected to the stack on this, on the armature stack. So let me get this camera remounted, move my lights around, and we will do the continuity and ohm checks on the field windings. Okay, so the first thing I'm going to do is I'm going to check continuity from the wires to the brush holders. Alright, so we have continuity to one, not to the other. That's good. So this one, the white wire, should have continuity here, which it does. Go on the back side here. It does not. Now we want to check continuity between the brushes, which we don't have. And just as a double check, which they shouldn't, continuity between these, which if it didn't have continuity back there, it shouldn't have continuity here. It's just a double check. Okay, so we know we have continuity. Let's go to our lowest resistance setting, which on this one is 200 ohms, and let's check the resistance between the wire and the brush holder, and they should be really close together. I'm reading about 0.3 ohms on the hot wire side, and I'm reading like that. And I'm reading about 0.5 ohms on the common side. Alright, that is a difference, but I'm not entirely certain that's enough to be an issue. Okay, so 0.2 ohms difference from one side of the field to the other. Let's check again for a hot wire to the stack. Nothing. Common wire to the stack. Nothing. Okay. So we may have a little something going on in there, but honestly, I'm not really seeing anything that raises too much of a concern. I am going to take this outside. I'm going to shoot some electrical contact cleaner down in it and blow it out, and then we'll get to testing the armature. Okay guys, so I've got the field windings outside drying from where I cleaned them out, and while that's drying out and everything, the wind's blowing a little bit, so you might hear some wind noise. But what we want to do is we want to check all these commutator bars to see how much resistance is between the one directly across from each bar and adjacent. Now, the resistance doesn't have to be the same. However, you do want it to be somewhat close. Now, when I was pulling this out, I also checked these bearings. Everything felt really good. I don't see anything giving a lot of resistance to the electric motor. So I have my multimeter on my lowest resistance setting, which is 200 on this one. And the first thing I'm going to do is I'm going to go across 180 degrees from each other. I know you can't see that right now, but that's 0.6, 0.7, alright, so everything there is 0.6 to 0.7, which is about what you would expect it to be. Okay, so we checked the 180 all the way around, and everything was between 0.6 and 0.7 ohms. Very, very close. I don't see a problem there. So what we're going to do now is we are going to check the bars next to each other. So about 0.3, 0.3. Alright, so we went all the way around, and everything was about 0.3 to 0.4. There was one is like 0.7. It was a little high, and it is different, but I don't think it's going to be enough to matter. So the last check we want to do is, it's just a continuity check, so I'm just putting my meter on continuity. And what we want to do is we want to make sure that none of the commutator bars have continuity with the shaft, which is, has the stack attached to it. If you are dropping, or if you have continuity to the stack or to the shaft, then you are dropping straight to ground, and it would cause a breaker to trip, such as we are seeing. So if it makes this sound, that's not good. And we'll just go around. Have a clean commutator. Before we started, I took some 800 grit sandpaper, kind of polished this up a little bit. Alright, so I didn't get any continuity anywhere on this armature. Like I said, the bearings are free. I checked the gearbox where the blade hooks. I'll show that to you here in a minute. Everything spins really freely. I don't see, other than possibly the brushes being bad, or maybe just some of that metallic dust that was up in the motor may have been causing an issue. That's entirely possible, I guess. But I'm going to reassemble this thing and see if it works. If it doesn't work, I really don't know what else to do for this. Like I said, they don't make parts for it anymore. They make a unit that is very similar to it. It looks almost identical, but the parts are a little different. And I did look at the part numbers on the new version and this version, and other than the brushes and maybe a few of the little plates that hold the abrasive wheel on, screws, the vise, the base, things that are not going to contribute to an electrical issue, those are interchangeable, but all the electrical components were not. So I'm not going to put any money into this and try to find a used one that may or may not work. If I put this back together and it doesn't work, I'm probably just going to scrap it and get a newer one. Okay. Oh, that's a powerful odor. So I got everything put back together and pulled the trigger on it, and yeah, she burned up. Obviously a short up in there somewhere that we couldn't detect with our test. So this will be going away, and I'll just be buying a new one. Sorry we couldn't make it work, but at least we got some got to cover some testing and things of that nature. Yeah, so thanks for watching. We'll see you next time under the shed.